Okay, in this example, we're going to be finding theta, okay? We're going to find the value of theta. Or you could say we're finding the measure of angle B, since angle B right here is the one that's labeled with theta. All right, let's take a look at what we have here. From theta, we know that this side right over here is opposite that angle. We know that this value right here is adjacent or next to the given angle measure. The side opposite the 90 degrees is always the hypotenuse. Okay, we have opposite and adjacent that have values on them. Which trig function uses those two sides? Now let's try and remember, before I say the actual value, okay, before I say which trig function it is, here's a little hint, okay? That wonderful little acronym, that SOHCAHTOA acronym. If you guessed tangent, you are correct, because tangent uses opposite and adjacent. So let's set this up so that we can find tangent. So we have tangent of theta is going to give us 6/8. What on earth are we looking for? We're looking for theta. This time we're looking for the angle measure. So we can't use any of the things that we have learned in the past. We got to use something brand new and different if we want to be able to find this trig function's angle. Now, when we're finding angles and we have a ratio of sides in a trig function, we can use what's called the inverse to find the angle measure, which is exactly what we're going to do here. Okay, now I'm going to take the inverse of both sides, but for right now, let me just start with this side. Okay, now the inverse is going to look like that, where it has the -1 exponent on top. Okay, that just means that it's the inverse. Its technical name is the arcsine, or arctangent in this case. Okay, arc, whatever the trig function is. So arcsine, arccosine, this one's arctangent, or inverse tangent. And we're going to do the same thing over on this side. I wrote it really close, so I'm going to have to write it right there. Okay, so what does the inverse do? Well, kind of like how exponents and radicals will cancel each other out, multiplication and division go together, addition and subtraction go together, inverse trig functions and trig functions will also go together. So those two values are going to cancel out and we're left with theta. On the other side, we have this value that we're now going to need to calculate. Okay, so the inverse tangent of 6/8. Now, that's not something that you can easily do by hand. This is something that you're going to need to use a calculator for. So if you have your calculator, you will want to type this in. Okay, inverse tangent of 6 divided by 8. And you should end up with the following value. Okay, you should end up with something like 36.869897 da 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 da. It goes on forever and ever and ever. Okay, now rounding is going to be very, very, very important from henceforth. Okay, forever and ever. Rounding is always important, but from here on out, it is extremely important. We're going to round to 3 decimal places. Okay? So I underlined the third decimal place. We're going to look at the value right next to it. Since the value next to the 9 is 5 or greater, we need to round up. But when we round up to 9, that 9 up, it actually gives us a value that's bigger than just a single digit. So we end up with the following value for theta equals 36.87 degrees. Okay, so 36.87 degrees. You don't necessarily need that 0. I'm going to incorporate it because I did say I was going to round to 3 decimal places. I don't think my explanation for the decimal made total sense, so watch the next video and I'm going to have a cleaner and better explanation for that.